Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have completed chapter number 11, Constructions. Hope it was clear for you all. In today's session, we shall discuss a new chapter, that is chapter number 11 from NCERT textbook, Surface Area and Volume. Let's move on to the topic.
Surface area of cube and cuboid. A cuboid is simply a box like this. It is three-dimensional as it does not occupy a part of just one plane. Three things define a cuboid: its length, its breadth, and its height. This is a cuboid. What will be its total surface area? As the name suggests, it will be the total area of all its surfaces. A cuboid has 6 surfaces in all, one at the front and one at the back. Their areas will be equal as it has the uniform cross section. Area of each will be L into H and the total area will be 2LH. Similarly, the sum of the areas of the faces at the top and at the bottom together will be 2LB, and the sum of the areas at the faces on the right and left are 2BH. That is the total surface area of a cuboid. If you take 2 common, we can write it as 2 into LH plus LB plus BH. What is the lateral surface area then? The word lateral simply means side. This is a sum of the areas of the faces on the side, not the faces at the top and the bottom. So, it will be 2 into LH plus BH. We ignore 2LB as they are the areas of the top and the bottom surfaces. These are the two types of areas we have to understand. The last concept is that its volume. The volume of a cuboid is simply the product of its length, its breadth, and its height. To be more specific, it is the area of its base times its height. Next, we shall discuss the concept of a cube. It looks similar to a cuboid. It has length, breadth, and height, with only difference be that all that are equal. Let's say each S units. If each of the sides are equal, then each face will be a square, and the area of each face will be a square. As there are 6 faces, the total surface area will be 6 S square. What will be the lateral surface area and volume then? As it has 4 faces on the side, and its lateral surface area will be 4 S square. As L, B and H are equal to S, the volume of cube will be side cube.
Next, we shall discuss exercise 13.1, first question. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is to be open at the top. Ignoring the thickness of the plastic sheet, determine the first question, the area of the sheet required for making the box. Here, let's go through the question again. A plastic box. Plastic box means it is in the shape of a cuboid. Length is given to us 1.5 meter, width or breadth is 1.25 meter, and deep or height is 65 centimeter. Here when you check the units, this is in meter, this also in meter, but this is in centimeter. So you have to convert all in same unit. Means better to convert this one into meter. 65 centimeter we have to change to meter. And this much dimensions we are using and making a box. Means it is in the shape of a cuboid. There is a condition, it is to be open at the top, means the top portion is open or the top of box is not there. Ignoring the thickness of the plastic sheet, ignoring the thickness means no need to consider the thickness. Determine the first one, the area of the sheet required for making the box. How much sheet is required for making the box? So let's visualize the question first. There is a box which is in cuboidal shape length is 1.5 meter, height is 65 centimeter, and breadth is 1.25 meter. So let's write all these things. Length is 1.5 meter, breadth of the box 1.25, and depth or height is 65 centimeter. Here this 65 centimeter we have to change to meter. So centimeter to meter conversion is divided by 100. So 65 divided by 100, that is equal to, here when you check in the denominator there are two zeros along with 1. So the decimal form will come as after decimal 2 digits or 2 places. So that is equal to 0.65 meters. That is the depth of the box. Now let's see how much area is required. Area of sheet required is equal to area of cuboid. Area of cuboid in the sense total surface area of cuboid. So total surface area, the entire surface of cuboid, minus, it is according to the question mentioned here, it is to be open at the top, means this top portion is not there. So that area we have to remove. So just as per the condition only we have to make the box. So total cuboid area, the total surface area we calculate, and from there upper portion box upper portion is not there, it is open. So that portion area we have to remove. So area of top which is open. So the area of top, that means it is just same as the bottom one. Length is 1.5 meter and breadth is 1.25 meter. Total surface area of cuboid, we know the formula, 2 into LB plus BH plus LH minus area of top. Area of top is, it is a rectangular shape, length into breadth. So it is mentioned here. First let us do the calculation part here. Simplification we must do it here. Then we can go for substitution. That will be easy. So that is equal to, when you remove the bracket, 2 into LB plus 2 into BH plus 2 into LH minus L into B. And here 2LB minus LB. 2LB minus LB is 1LB. That means LB. These two remains the same. So LB plus 2BH plus 2LH. Now the formula is simplified. We can go for substitution. That is L into B. L is 1.5 into 1.25 plus 2 into BH. BH is 1.25 into 0.65. 1.25 into 0.65 plus 2 into LH. L is 1.5 meter. H is 0.65 meter. So let's go for multiplying this one. So here I am not showing the rough calculation. What you are supposed to do is, you are supposed to do the calculation on the right side of your notebook. When you write this answer, on the right of this answer you have to do the rough calculation. That is 1.5 into 1.25 you have to multiply. You have to verify that you are getting the answer 1.875. 2 into 1.25 into 0.65 you have to multiply. You will get the answer as 1.625. Plus 2 into 1.5 into 0.65, when you multiply you will get it as 1.95. So please do not copy, do the calculation and write the answer, and you must show the calculation on your notebook when you send the notebook copies. So these three quantities when you add, 1.875 plus 1.625 plus 1.95, you will get the answer as 5.45 meter square. So the first part answer is over. The area of the sheet required for making the box, 5.45 meter square area of sheet is required. Now the second portion, cost of sheet. Cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20. 1 meter square sheet costs rupees 20 means we need 5.45 meter square of sheet for making the box. So we have to calculate how much amount. The given condition we will write the cost of sheet per 1 meter square area. 1 meter square area cost is rupees 20. So required area for us is 5.45 meter square. We have already calculated and kept here 5.45 meter square. So 1 meter square rupees 20. Then cost of 5.45 meter square area of sheet is 5.45 into 20. Once again, 1 meter square cost is 20. 5.45 meter square area is 5.45 into that 1 meter square value, that is 20. Area into the rate. Here this is called the rate. Per meter square how much cost is there, that is called the rate. So area into rate, 5.45 into 20, that is rupees 109. So the cost of sheet is rupees 109 and the area of sheet required is 5.45 meter square. Next, we shall discuss question number 2. The question is, the length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.50 per meter square. Let's go through the question once again. The length, breadth and height of a room means the room is in the shape of a cuboid. Length is given to you, breadth is there and height also given to you. Find the cost of whitewashing the walls. So the area which is to be whitewashed, that is what we have to calculate first. So and the ceiling, 4 walls and the ceiling, that much area only we have to whitewash. Floor no need to whitewash. So 4 walls and the ceiling of the room we need to whitewash at the rate of rupees 7.50 per meter square. Cost is given to you. It is called the rate. In the previous question we have explained already. Rate means per meter square, means 1 meter square how much is the cost. So here 1 meter square cost is rupees 7.50. So that is what we have to, it is given to us. So let's visualize the question. Here this is the shape of a room. Length is there 1.5 meter and breadth is there 4 meter and height is there 3 meter. And the area which is to be whitewashed, that is 4 walls. Here front there is 1 wall and the side right side there is 1 wall and left side there is 1 wall and behind or back this is the one 4 walls and the top portion, that is the ceiling. This much area only we need to whitewash. Means the total area, total surface area of cuboid, we need not to calculate this area, means floor area. That is what we have to consider in this question. So length L is L of the room, that is equal to 5 meter. Length is given to us 5 meter, breadth is 4 meter and height is 3 meter. Length is 5, breadth is 4 and height is 3. It is given to us. Then area to be whitewashed. The area which is to be whitewashed is area of cuboid. Just like the previous question, the entire area of cuboid we will calculate. That is the total surface area of cuboid we will calculate. From there we have to minus, because this floor portion no need to consider. In the previous question, box question, upper portion is opened, top is open, so that portion we didn't consider. Here in case of whitewashing, floor we will not whitewash, so that portion, area of base, we have to remove. Area of cuboid we know and area of base formula also we know. So let's consider this base separately. This is the base or the floor. Length is 1.5 meter and breadth is 4 meter. Then area of cuboid, we know the formula, 2 into LB plus BH plus LH minus area of base is L into B. Here also we will go for a little bit of calculation. After that we will go for substitution. So 2 into LB plus 2 into BH plus 2 into LH minus L into B. Then 2LB minus LB, 2LB minus LB is LB plus 2BH plus 2LH. Then substitute it. Calculations are a little simple here because comparing to the previous one, because previous one decimal representation was there. Here there is all single digits. So L into B, 5 into 4 plus B into H, that is 4 into 3, 2 into 4 into 3 plus 2 into LH, that is 2 into 5 into 3. When you do the calculation, 5 into 4 20, 4 into 3 12, plus 12 into 2 24, then 5 into 3 15 into 30. When you add this, there is 74 meter square you will get. So area need to be whitewashed is 74 meter square. But what we have to calculate is we have to find out the cost of whitewashing. So cost of whitewashing, it is given to us per meter square, means 1 meter square area, it is given to us 7.50. So we are having 74 meter square area. The cost of whitewashing 74 meter square area is equal to 1 meter square 7.50 rupees, and 74 meter square means 74 into 7.50. That is equal to 74 into 7.50. You have to multiply it. As I mentioned before, please do not copy, just to do the multiplication on the right side and verify that you are getting the answer as rupees 555. So the cost of whitewashing is equal to rupees 555. Next, we shall discuss question number 3. The floor of a rectangular hall has a perimeter 250 meter. The cost of painting the floor, 4 walls at the rate of rupees 10 per meter square is rupees 15,000. Find the height of the hall. Floor of a rectangular hall has a perimeter 250 meter. Rectangular shaped floor. Perimeter is 250 meter. Then it is a hall. Hall means just like a room, cuboidal shape. Then here it is, floor is in rectangular shape and the total hall, entire hall is in cuboidal shape. Perimeter of rectangle is given to you 250 meter. Cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000. So cost at the rate means per meter square, 1 meter square rupees 10. Then the total cost or total money which we spend is 15,000 for painting. Find the height of the hall, that is what you have to calculate. Let's visualize the question. Consider this one as a hall, cuboidal shape. This is the top of the hall. This is the floor of the hall that we know now. Here 4 walls, front, right side, left side and back side. So these 4 walls only painted. And there is no dimensions are given. Length, breadth, heights are not given. So just take it as L, B and H. So let length, breadth and height of the rectangular hall be L meter, B meter and H meter respectively. Given to us the floor of the hall, perimeter is given 250 meter. So floor means it is a rectangular shaped one, that is length, and another one is breadth. And perimeter of the floor of the hall is 250 meter. So perimeter of rectangle, we know the formula, that is 2 into L plus B is equal to 250. Then from here L plus B we can calculate. This 2 it will come to the right side, that is 250 by 2. So L plus B is equal to 125. Let it be equation number 1. Then area of 4 walls. That much only we are just painting. Area of 4 walls means total surface area of cuboid. Total area we will consider, and we will remove which are the areas we no need. We no need to paint. Those areas we have to remove. So total cuboid, floor we need not paint, and top also no need, because it is mentioned here painting 4 walls only. So total 6 faces. Then top and bottom no need. So area of floor and area of top. So area of floor somewhat here, and top of the hole also same only, length and breadth is there. Okay. Then area of cuboid formula 2 into LB plus BH plus LH. Area of floor formula L into B. Area of top also L into B. Let's remove the bracket. 2 into LB 2LB, 2 into BH 2BH, 2 into LH 2LH, minus LB minus LB. Then here minus LB means minus 2LB. So minus 2LB plus 2LB gone. So 2 into LH plus BH will be coming. From here H and 2 we can take common. So 2H into L plus B. So this is actually a common formula we used to study. Instead of writing these 4 steps, area of 4 walls, you can by heart or you can use this formula directly. It's not a problem. 2H into L plus B. This is the lateral surface area of cuboid. So 2H into L plus B directly we can write and do, or else this one derivation part also you can do and calculate. So which one is convenient for you, that way you can do it. Here we have now L plus B value, that is 2H into L plus B is 125. Substitute. So 2H into 125, that is we are writing by using equation number 1. That is 2H into 125 is 125 into 2, 250. 250 H meter square will be getting. So this is what area of 4 walls. Now you have to use this condition. Rupees 10 cost of painting 4 walls at rupees 10 per meter square is 15,000 rupees. By using that condition we have to start calculating H. So area 4 was 250 h meter square. Cost of painting per 1 meter square area. 1 meter square area cost is rupees 10. Then we have 250 h meter square area. Cost of painting 250 h meter square area is rupees 10 into 250 h. 1 meter square is rupees 10. Then 250 h meter square means 250 h into 10. That is what mentioned here. Then cost is given to us 15,000. Here instead of cost, you have to substitute 15,000, and the right side remains the same. 10 into 250h, that is 250 into 10, 2500h. Here let's calculate h. This 2500 will be coming as denominator here. So 15,000 divided by 2500. Then here cancellation can be done, and finally h will come as 6. So the value for h, or the height of the wall, is 6 meter. That is what the question, that is what the answer. Height of the hall is 6 meter. Next we shall discuss question number 4. The paint in a certain container is sufficient to paint an area equal to 9.375 meter square. How many bricks of dimensions 22.5 centimeter by 10 centimeter by 7.5 centimeter can be painted out of this container? Here let's go through the question again. The paint in a certain container is sufficient to paint an area equal to 9.375 meter square. So a container is having paint, and the area which can be painted by using that paint is 9.375 meter square. There are bricks, dimensions are given 22.5 centimeter by 10 centimeter by 7.5 centimeter. How many of such bricks can be painted out of this paint? That is what the question. Here first of all you might have noticed this one. Here meter square, here it is in centimeter. So units are different. First thing, we have to change the units into the same measurement like meter or centimeters. Here better to convert this meter to centimeter. So here let's visualize the question first. There is a brick. Length is 22.5 centimeter, breadth is 10 centimeter, and height is 7.5 centimeter. And the given condition is area that can be painted by the container is 9.375 meter square. Here meter square is the unit given to you, and other units are in centimeter. So let's convert this meter to centimeter. So meter to centimeter, we know that it is into 100. Here meter square to centimeter square we have to convert. So meter square, if you are changing, you have to put 100 square, multiply by 100 square. Meter to centimeter is into 100. Meter square to centimeter square is just to put a square, 100 square. That is equal to 9.375 into 100 square is 10,000. When you multiply it, you will get the answer as 93,750 centimeter square. When you multiply these two, you will get as 93,750 centimeter square. So here 3 digits are there after decimal, so 3 zeros will go. That means 9375 will come. Again one more zero balance here that you have to put. That's all. Multiplication, I think it is clear. Then total surface area of the brick, because this brick only we have to paint, so we have to find out the total surface area. So 2 into LB plus BH plus LH, just substitute it. 2 into 22.5 into 10 plus 10 into 7.5 plus 22.5 into 7.5. As before, just to do the calculation, that is 2 into 22.5 into 10, 225, 10 into 7.5, that is 75, 22.5 into 7.5, that is 168.75. Do the multiplication on the right side. Then when you add this, you will get as 2 into 468.75. When you multiply it, you will get 937.5 centimeter square. Once again, please do not copy this one, just to do the calculation on the right side. So number of bricks that can be painted out of the container. That is what the question. How many bricks can be painted? So number of bricks, total number of bricks means here area is given to us. That is 937.5. That is area of one brick. And total area which can be painted by using the paint is 93,750. So number of bricks that can be painted out of the container is area that can be painted by the container, that is this one, 93,750 divided by surface area of one brick. This is area of one brick. That is equal to 93,750. That is the total area which we can paint by using the given quantity of paint. 93,750 we substituted. Surface area of one brick. Total surface area of one brick is 937.5. So here in the denominator there is a decimal number. After the decimal point there is one digit. So to avoid this decimal portion we have to multiply 10 in the numerator, because there is only one digit after the decimal. So you can multiply 10 in the numerator and 10 in the denominator. So numerator becomes 937500. One more zero will be more here when you multiply 10. And the denominator, when you multiply 10, what will happen is the decimal portion will go. That is 9375 will come, no decimal. Then you can see here 9375, 9375 can be cancelled and you will get the answer as 100. So number of bricks that can be painted out of the container is 100. Move on to question number 5. A cubical box has each edge 10 centimeter and another cuboidal box is 12.5 centimeter long, 10 centimeter wide and 8 centimeter high. Which box has the greater lateral surface area and by how much? First question. Here let's go through the question. A cuboidal box, sorry, a cubical box. Cubical box means it is in the shape of a cube. Cube is having only one dimension, that is the side, 10 centimeter. And another cuboidal box is 12.5 centimeter, 10 centimeter and 8 centimeter high. Another box which is having cuboid in shape. First one is cubical shape, second one is cuboidal shape. Cuboidal means it will be having length, breadth and height. Question: which box has the greater lateral surface area and by how much? So we have to find out the lateral surface area of these two shapes and we have to compare. The first one is a cube, side is given to you 10 centimeter, and the second one is a cuboid, length is 12.5, breadth is 10 and height is 8. It is what is given to you. So for cube the dimensions we have to write, and for cuboid also we have to write the dimensions. Edge of cube is given to you 10 centimeter and the length of the box is given to us 12.5 and breadth is given to us 10 centimeter and height is given to us 8 centimeter. Go through the units, here in centimeter, here also in centimeter, so no conversions. Then lateral surface area of cube, we have learned the formula 4 into side square, that is 4 into side is 10, 4 into 10 square is 4 into 100, that is equal to 400 centimeter square. That is the lateral surface area of cube. Then for cuboid lateral surface area we have already learned this one. Either you can derive or you can directly write. So 2 into LH plus BH, that is equal to 2 into 12.5 into 8 plus 10 into 8. 12.5 into 8 plus 10 into 8. Another formula also is there, that is 2H into L plus B. That also can be used. It's not a problem. Which one is convenient for you, that one you can use. Here 2 into LH plus BH I have used. 2H into L plus B also is their formula, means H we are taking outside and doing the calculation. That also can be used. So that is equal to 2 into 12.5 into 8 is 100 plus 10 into 8 is 80. That is 2 into 180, that is equal to 360 centimeter square. So which box has the greater lateral surface area? So here the lateral surface area of cuboidal box is, cubical box is 400. That means 400 is greater compared with 360. So lateral surface area of cubical box is greater than the lateral surface area of cuboidal box. Cubical box is more than the cuboidal box. So lateral surface area of cubical box minus lateral surface area of cuboidal box we have to do, because by how much that we have to calculate, means the difference is how much that we have to calculate. So the bigger surface area, lateral surface area minus the smaller lateral surface area, that is equal to 400 minus 360, that is equal to 40 centimeter square. So the first part answer is over. Therefore, the lateral surface area of the cuboidal box is greater than the lateral surface area of cubical box, by 400 centimeter square. The lateral surface area of cubical box is greater than the lateral surface area of the cuboidal box by 40 centimeter square. The first part is over. It's a direct question. If you know the formula, you can do it. Then the second part, which box has the smaller total surface area and by how much? Which box has the smaller total surface area and by how much? That will be the second question. So that portion you will do it as homework. Dear students, today we have discussed the surface area and volume of cube and cuboid. And also we have solved first 5 questions from exercise 13.1. I request all the students to solve these 5 questions in a separate sheet of paper. And while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.